Hello everyone, welcome to this lecture on basic operations in NumPy array. In this lecture we are going to discuss various operations like concatenation, appending elements to an array, and also various other functions. We'll start with the first concat function. This function is used to join two arrays along rows. So we have to specify this axis. So this concat function, first we have to create two arrays. Array 1 contains two rows and two columns, and second array contains one row and two columns. Since the columns are same, column dimension is 2, we can join these two arrays. So array 1 and array 2 will be concatenated along rows. We also have append function. This function is more flexible than concatenation function because we can append a scalar or a 1D array to a higher dimensional array. But if we deal with arrays of the same shape, then we have to go for this np.concat function. It will be more efficient. So this explanation for that, the output of this is 1, 2, 3, 4 and 5, 6. So 1, 2, 3, 4 are the elements of the first array, 5, 6 is the elements of the second array. Since the dimension, column dimension is same, it is 2, so we can join this along rows. So we have a specified axis equal to 0, that means that we are joining these elements along rows. The next function is append function. We can use this append function to add elements at the end of the array. We can add either one element at the end of the array or multiple elements at the end of the array. So in the first example, first we have created an array with the 3 elements 1, 2, 3. Then we are appending one more element at the end, that is 4 is appended to this array. In the next example, we have created a 1D array with 1, 2, 3, 3 elements, and then we are adding multiple elements now. So 5, 6, 2 elements are added to the end of the array. In the next example, we are going to append rows to a 2D array. So the first array 2D array contains 2 rows, 2 columns. That is, we have 1, 2 at the first row, 3, 4 at the second row. Now we have to use this append function to add one more array that stores 5, 6 in the next row. Since we have added based on the row, so we specify axis is equal to 0 over here. Similarly, we can add elements to a 2D array based on column. So here first we have created a array with the given elements 1, 2 and then 3, 4. So now we have to add one more column to it. So 5 and 6, this will be added at the third column. So we have to specify axis is equal to 1 because we are appending these elements at the third column. So axis should be 1 if we are performing these operations based on the column. So here we have to understand that when we append rows or columns, the dimensions must match. The next function is NumPy.stack function. This function can also be used to combine arrays along a new axis. So we have to specify two arrays. First we have created two array A and B. Array A contains two elements 1 and 2. Array B contains two elements 3 and 4. Now we have applied this stack function to join these two arrays. We have generated the output, that is 1, 2, 3, 4. So we have combined this based on a new axis along rows. We have combined these elements. The next function is split function. We can split the given element of an array into the equal sized subarrays. We have 6 elements in this array. Now when we execute this split function on this given array, we have specified 3, so that means the array will be split into 3 equal sized subarrays. So since we have 6 elements, each subarray will be containing 2 elements. The next function is sort function. We can arrange the elements of a given array in an increasing order. For that we have called this sort function. We have passed this array variable inside it. So this returns a sorted array. The next function is var function. It is used to find an element, find the index of a specific value in the array. We can use the array variable to mention a particular element to be searched. So first we have created an array, then we are trying to find the index of the value 50. So in the var function we have said array is equal to 50. That means it returns a tuple of arrays for the statement np.var array is equal to 50. The first element of the tuple will contain the index where the condition is true. So it will be printed as the index. In the next example, we assign 50 to a particular variable element and we are trying to find the index of the element. So here we have to check in the var function array is equal to element, and we can check whether the element is found or not by placing this condition. If index of 0 dot size is greater than 0, then we can say that the element is found at a particular location. Otherwise we can say that the element is not found on that. The next function is to search for multiple values. We can find multiple values. For that we have to pass a list or array of values to np.esin function, and then we have to use np.var function. So in the np.esin function we are passing the array and another array that contains values to be searched. So this esin function will create a boolean array. It indicates that the values in the array are in values to search. So the np.var function need to be used to return the indices where the mask is true. So first we have created an array values to be searched with these 3 elements. Next we are checking whether the elements in array are in this particular values to search array. Now this esin function will generate a boolean array to indicate where the values in array are in values to search, and then we are finding the indices where the mask is true. We apply a var function here. This will print indices of values 30, 70 and 100. The next function is argmax and argmin. We can find the maximum value indices or minimum value indices in an array. For that we have to use this function. The next function is var function for searching element in a 2D array. So we can find the index of value 5 in this 2-dimensional array. So this 2-dimensional array contains 3 by 3 matrix form. So this element 5 is at index 1 comma 1, that is row 1 column 1. So that will be printed as the output. So to get this index values, first we have to find the index of the value 5 using var function. So we check whether array contains 5. It generates the index of the value. Then we are splitting that index into row index and column index. Finally we are printing it. The next function is slicing function, iterating function, and here we can also use indexing function to access element at a particular position in an array. So first we have created an array with 2 rows and 3 columns, and suppose we want to access element at row 0 and column 1. So at row 0 and column 1 we are having the element 2. So that will be printed. For that we have to use the indexing like this, array of 0, 1. That means at 0th row and column 1 we are accessing the element. And then in the next function, in the print function, we have to pass array of starting with the beginning and going to the end, and that means all elements, all rows will be sliced and column 1 will be taken. So it slices all rows and column 1 contains element 2 and 5, that will be printed as the output. So we have applied a slicing function over here to print 2, 5 from column 1. The next function is iterating function. We can iterate through the array. First we have created array with a 2 by 2 size. For each row in the array we are printing the element. For each row we are accessing the element in the row. So the element will be printed one after another. The next function is copy function. We have two types of copying, shallow copying and deep copy. The shallow copy stores references of objects to the original memory address, but deep copy stores copies of the object's value. So any changes made in the new array will be affecting the original array in case of shallow copy, but in deep copy the changes in the new array will not affect the elements in the original array. So that's the main difference. And shallow copy is faster than deep copy. So that is another point you should remember. So here in shallow copy method, it stores the copy of the original object and points the references to the objects. But deep copy stores the copy of the original object and recursively copies the objects as well. So that's why the changes made in the new array will get reflected in the original array in case of shallow copy, but in the deep copy it will not reflect the change. So now let us discuss the example for this. So first we have created an array with 3 elements 1, 2, 3. If you print this array, we'll get 1, 2, 3. Then we are creating a shallow copy of it using the view function. So if you print this copied array, we'll get 1, 2, 3. Now suppose you are making a change in this array. Let's say array copy is equal to copy of 0 is equal to 99. So that means the element at the 0th index is modified. So instead of 1 we are getting 99, 99. So if you print both the array, you can observe that the change would get reflected in the original array as well. In the deep copy, we create a array first and then we apply a function, copy function, to check whether it is copying the array. So we are getting the same elements of the original array in the new array. So if you make any changes, it will not get reflected in the original array. So the next function is reshape function. In this function we are changing the size of the array to 2 cross 3. So 2 rows, 3 columns. Now we apply transpose function, matrix operation, to change the rows into row into column and column into rows. So in the first row we have 1, 2, so it will become the first column, and in the second row we have 3 4, it will become as the second column. So array dot t will generate the transposed array. The next function is identity function. For this we use a I function. We can call this I function using np.i, and we can pass the dimension. So 3 is passed over here. That means we are going to have a 3 by 3 identity matrix. So in this identity matrix, all the diagonal elements will be 1. All the other elements will be 0. So in this function, we can set k is equal to 1. That creates a identity matrix, 3 by 3 identity matrix with 1 on the diagonal above the main diagonal. So if you set k is equal to 1. The next function is universal function. For this we have a built-in function called square function. You can call this function using np dot operator, and you can pass the array variable. So each element of the array will be squared up. So square of the 1 is 1, 2 is 4, 3 square of 3 is 9. So that will be the output of this function. So here we have understood that the operations on array is performed element wise. So that's all in this lecture. Thank you all.